one line of code. We're testing a very small piece. It's called unit testing. The other style of testing that does, in a way, is called test-driven development, where the tests exist before the code that it's testing exists. And we're going to hopefully do a little bit of a demo of that today. So it seems a little backwards, right? How can you write a test that validates code that you haven't written yet? We're going to talk about why a lot of people do that, the pros and cons of that. The other style of testing, once you get beyond unit testing, you're just testing one function, is functional testing. Does this code function the way I want it to function? Which may require testing more than one method at a time. Does my code work together to solve the problem that I'm looking to do? And then we have integration testing, which is when I put all of the things together and integrate my template and my express server and my validation. When I test all of that together, does that do what I want it to do? And at the far outside, we have what we would call acceptance testing or user testing, which is, does this solve the problem that my boss, my project, my company assigned me to do, right? Did I build a calculator? If you think about the calculator problem, right? Does this actually work as a calculator? So, right, many different levels of testing, a couple different styles of testing. And then if you think about this as a spectrum, right? If you think of it as an onion, with unit testing being all the way on the inside, the core, the smallest thing, all the way out to user acceptance testing on the outside, we can process this a couple of different ways. We can start with unit testing and work our way out to acceptance testing. Or we can start with acceptance testing and work our way into unit testing. Holy smokes, it's like it seems like there's a huge matrix of ways you can do this, right? Test first or not test first. None of them are exactly wrong. There's a hand.
So you can use like multiple testing and work in like one code. Like it's not like you pick one and the other.
Every project will have all of them. Every project you do will have unit testing, will have functional testing, will have integration testing, and will have acceptance testing. If you are fully testing your application, you will have all of those styles of testing in every project. Right? So if you look at the calculator you did, right, what might be a unit test for your calculator? Do we have an example of what a unit test for your calculator might have been?
Like to see if it adds.
Right, yeah. So if I have a function that adds two numbers, if I give it two numbers, does it add it? I have a function that says take two numbers and multiply it, do they multiply? Right? What might be an integration style test for the calculator, right? Something that ties a couple of functions together. Yeah, it equals, right? Or maybe when I put 2 plus, do I see the bar at the top change, right? If I get equals, do I get the response? Right? Integration testing might be, hey, do the buttons work on the page, right? Because you can test the equal sign and the plus without the user interface. So now, integration tests will say, okay, I know my equals work, but does it work when I press the equals button in the actual user interface? And user testing, acceptance testing would be, does this work like a calculator? So can I write a test that says, start up my calculator, press the number 2, press plus, press 2, press equals, do I get 4? So all of those styles of testing can and will exist in one project. Maria?
What I would do the lesson here, the question that I had was, are all the tests done at the same time? So
No.
Affect,
No. So as I said, right, so maybe with a calculator, so let's take that calculator example. You're writing a test. You might start, the very first test you might write is, can I add 2 numbers? Then can I multiply 2 numbers? Then I can divide 2 numbers. And then maybe the next test you write is, can I do the equals? And then the next test you do is, can I get the user interface working? And then the last test you do, does it work all together? Right? That's called inside-out testing. Start from the inside, the smallest bit of code, just adding 2 numbers, and start write that code and write that test. Then go out and write a little bit more code and a little bit more test, and then out and out and out. That's inside-out testing. Outside-in testing would say, start with a test that says, do I have a calculator? Then, yep. So, and then let that drive what the next thing is. So, do I have a calculator? The next thing that will drive is, well, I need a user interface. Okay, well, in order to have a user interface, I need to have buttons. Well, in order to have buttons, I need to be able to click on them. In order to click on them, they have to have somewhere to go. And then finally, I get down to having my clusters. Some people program outside in, some people program inside out. Right? So remember yesterday when Mark said that he would start with the data and then work to the user interface? That's an inside-out approach. Remember yesterday when I said I would start with the user interface and work my way in? That's outside-in approach. Both of them work. They have pros and cons, and we're happy to discuss them, but maybe not in detail this morning.
Are there certain projects that, depending on whatever it is, you flip from one to the other?
Totally.
Yes, totally. So if I were working on an application that had a lot of user interface requirements, like that the interface itself is really complex and big, I would probably start outside in. Because the most important thing is this interface. So if you're building something that's highly reliant upon the interface being successful, then I would start on the outside, because that's the most important thing. If I were building something that the most important thing was the data, like, I don't know, financial transactions, I would start on the inside. Right? The most important thing is that we get the balances correct. You'll often find sometimes teams work from 2 different ends. Right? You've got the front-end team that's doing outside-in development, where they're saying, I'm going to build this user interface. I'm going to assume that the back-end works. Right? I'm going to assume that all the lower levels work, and I'm just going to get dummy data. Remember like the customer database that we did? I'm going to get some dummy data. I'm going to do all the testing on the outside to make sure it works. While the back-end team is like, okay, I got to get a database, and I have to have rows, and they're working on the data, and they're working their way out. And you're going to meet somewhere in the middle. Like when we build bridges from 2 different ends, right? When we built the new Skyway, right? They built it from 2 different ends, and they met in the middle. They were off by a couple of feet. Oops. Right? But hopefully your team works towards the middle, right? So that's the front-end team doing outside-in, the back-end team doing inside-out, meeting in the middle.
So where they meet in the middle, does anyone know what that part of the whole thing might be called?
Integration.
Mm-hmm. Yep. Yep. What would they be using to talk to each other? And it's an abbreviation.
No.
Closer.
Closer.
Wait.
API.
API.
Yes. Yes. The API, that's where the back end and the front end would be talking to each other using a common API. They might even agree on what that API is going to look like in advance. And the front end works on the interface and making it adhere to an API that doesn't exist yet because the back end is starting at a low level and working towards building their side of that API. And then when the 2 things come together, you have a working application for full stack.
So both of those sides are working and testing against that API. When we finally connect the 2, they should just work. You know, bugs will be there, but they should just work. So the more that we test against that, whether we're doing outside in or inside out, what we're doing is we're guaranteeing that software works the way we want it to. Cool. That's like the 30,000 foot overview of testing. We could probably teach a 12-week class just on testing. It's a huge, huge subject. Again, it's one of these subjects that you're just going to get better at the more that you do. I will tell you it's another subject where you're going to feel it's painful to get started, because it is. My personal start with testing comes from 2 places. One where I was doing the aerospace defense stuff, right, the launching rockets. We had 6 times, 7 times, something like that, times more test code than we had actual production code. And our production code, when printed on paper, was like this high, right? And every line of code had to be tested. We had to document how it went, right? And I was ready to table flip on that when I got to doing web stuff. So I didn't test anything. Like, I'm free. I'm just gonna test. I'm just gonna write code. And then, like, my software had tons of bugs. So I actually started with this style of testing by doing defect-driven development. I would wait for there to be a bug, and I would prove that there was a bug by writing a test that duplicated the bug. So a user might say, hey, when I logged onto your site, I could see other customers' data. Oops, that's a bug. So can I write a bit of test code that says, if I log in as a user, do I only see my own data? And immediately that test would fail. Oops, yeah, sorry, I could see other people's data. And I would work on the code until that test passed and that bug went away. And I left that code in so that bug would never come back. Someone said so that you don't break old code, right? Right, I think you said that, right? So like old code doesn't break.
Yep.
And we slowly built up tests that way.
These would be regression tests to make sure you would leave that test in place to make sure that you never accidentally reintroduce that bug, aka a regression.
Yeah. The hard part is that writing tests will feel really slow. I mean, if writing code feels slow, writing tests for code will feel even slower. And you'll think like, oh, this is going to take me 10 times as long, and in the beginning it will. But what will happen over time is that writing tests will actually speed you up. Because debugging things is more expensive than not having to debug things. And eventually, writing test code will take less time than writing untested code that has bugs. So one of the things I heard this morning was like understanding errors and deciphering errors. As we start working on testing, watch how our opinion on errors changes from something that we fear to something that we utilize in our favor. Right? So in testing, we're going to use those errors as positive reinforcement and a way to guide our work, as opposed to like that sword we run into unexpectedly every time we run our code. Right. So I'm going to put the microphone back for Jason.
Yes. So I set up, while Gavin was talking, can y'all hear me in the back through the thing okay? Cool. So while Gavin was talking, I set up a package.json with just private true in it, a get-ignore that just has node modules in it, and I made 2 files here. In my source folder, where I would normally write all the code for my application, I just made an empty JavaScript file called sum.js. I also made another folder called tests, where I've put a file called sum.test.js. And in here, I'm going to write a function that sums up some numbers. In the other file, I'm going to write some tests that verify that that works. And it occurred to me that I'm also going to write some other arithmetic functions. And rather than having to make like a multiply.js, etc., I'm just going to make an arithmetic.js so I can keep them in one file. So, arithmetic. Arithmetic.test.js. Okay. So let's say in here, we have consum is a function. It takes 2 numbers and it adds them together, right? So return A plus B. I'm going to be all ES 2015 fancy, and I'm just going to make that nice and tiny. So we have this function, right? I know that it works, but let's write some code that proves that it works. Up until now, we might have just tried to do something like this.
Oops.
Whoops. Thank you.
How many people have done something like this in their code, right? We've all done the console log of work. You saw me do it yesterday.
There should be more hands.
Yeah.
Yeah, oh, thank you.
Y'all saw me do this yesterday while we were. Remember I said I can take small steps and see that it works. I said console.log we're here or request.send we're here. Like that's this kind of test, right? Some people might call this like a smoke test, right? Like can I light this fire and see there's some smoke?
Tracer
right?
bullets.
Tracer bullets, right? If I do this, do I see in my console or not, right? This is testing. It's not formal testing, but it's a style of testing.
And I probably don't want to leave this in my production code because, well, that's bad, right? Like I don't want to just dumping random messages when my code is running in production. Let's say I'm building a small library here that I'm going to use in my calculator app. Every time someone does a calculation, I don't want to just be printing random numbers to the log.
Yeah.
So I'm not going to leave this in here.
Yeah, if we had like a dozen developers on the team, and you go run the code, what you're going to see is 9, hello, this works, 43, something. You're just going to see all these random things.
Foo bar,
right.
foo berries.
Yeah, this doesn't work. go back and fix this, right? You think that your little log will be enough for you, and you'll remember later why it's there. But when you get on a team, that kind of style of dumping stuff out the log doesn't work anymore.
So I've moved my console.log to the arithmetic-test.js file. So instead of running that file, I'm going to run my test/arithmetic.test.js.
Uh-oh.
Womp womp. So here's the first error. And rather than being like, oh no, it's an error, I'm going to let the error guide me as to what to do next. Sum is not defined. Well, it makes perfect sense because the sum function is not defined in another function, and there's nothing in here that tells me, like, hey, like, use that sum function in here. So module.exports an object, and I'm going to say sum is my sum function. This is the thing that I'm exporting, right, is that. And I'm going to call it sum when I export it. So if I come up here and I say const I'm going to go up a directory /source/arithmetic. Did I? Thank you. Yeah. So here, let's try this, right? So let me think how the best. So if I leave that off, right? And I console.log arithmetic here. I'm gonna comment that out, and let's run that file again.
Raise clear.
It's yeah. Thank you. So when I try to require the contents of this file up here, even though that sum function is in here, when I required that file, all I got back was an empty object because I never exported anything from that file, right?
Just because you have functions in this file, when you try to require it, Node won't just expose all of those functions for you automatically. You have to be explicit about which functions are shared, exported, and which ones are not. So if you want the sum function to be used outside of this file when it's required, you have to explicitly teach Node that that's the case.
Yep.
So that's why he says the exports, the things that can be required from this code is sum, and if you say something.sum, you get the sum function. That's what allows this arithmetic to be this object. Right?
So now, if I run this again, whoops, module.exports, my bad.
Hey, look at that.
That's what the arithmetic variable holds now. It holds the key sum, which is a reference to the function sum, which is exactly what I exported from the other file. So now if I wanted to use my sum function, I could say, and we're going to make this a little bit better in a second. We're in a baby step there. Great. So I logged the arithmetic object, and then I called the sum function on the arithmetic object, gave it those numbers, and logged that. I don't want to say arithmetic.sum everywhere. I just want to say sum. So what I can do up here is say const sum is equal to arithmetic.sum.
I have a question.
Yes.
How come we couldn't call .sum on the method after required on
Up here,
Yeah.
we could.
Okay.
I'm baby stepping there. So that's a thing, but I'm going to show you something even better than that in a moment. So I run this, great, it console.log sum. However, there's some boilerplate up here that I don't like. I'm going to try to reduce some of it. Do you all remember that I said that if you have a variable with a name and you want to make an object that has a key with the same name, that you can just do this? And that's the equivalent? Okay. So there's an inverse to that. That's one side of it. You can actually do the opposite when you have an object and you want to pull a variable off of it by the same name. I can do this. and that works. So up here, I can just do that. So I'm requiring the arithmetic, but I'm pulling the thing called sum off of it and assigning it to a variable called sum. I never need to deal with the arithmetic variable in the middle. And I want to show you all this, not because you need to fully grok it, but because it's a pretty common pattern and you're going to see it out there. So just kind of accept that that's magic and it works, and we'll move on.
So I think the most critical thing out of the sequence that Jason did is if you comment out this line, and comment out that module export, and then go rerun your test again. This is the most important thing to take away from that sequence. Is when Jason ran this code, he got this error, right? And normally we're like, oh man, my stuff is broken, the world is ending. No, like we use this information. Most of the time, Node or Ruby or .NET or whatever language will help you see what the problem is, right? He got sum is not a function. And he's like, oh yeah, I don't know where this sum is. His next step is, I need to get the sum function into my code. If we work this way, errors tell us what the next step to do is. And I said we work with small steps. Right, so we work with small steps, and the errors tell us what the next step is. Almost all the time, we can just run our tests and let them tell us where to go. This also half solves the blank slate problem, right? That's another thing that I've heard a lot of people say is like, I don't know where to start. So Jason just started by writing code that says sum 4 and 5. I want to be able to add two numbers. I'm just going to write sum 4, 5 and get an error and see what to do. And JavaScript told him what to do. Like, oh, you don't have the sum function. Okay, well let me import that sum function from the library that I have. Right. So errors are going to start guiding us for our small steps, and they're going to start helping us solve the blank slate problem.
So just console.logging messages is not a very robust way of testing. And there's a number of test frameworks out there that help give us more helpful output, sometimes more helpful error messages than just 9, right? So what I'm going to do is I'm going to install a testing framework called Jest. Jest is by the same people who make React, and those are the people who make Facebook with React. So you kind of know just by going at the gate that like this test framework, it works. It works really well because it runs one of the largest websites on the internet. They write their code, their testing code in this. This is the tool they developed internally and then open source to test their front end stuff. So getting started, npm install. And we've talked about -- save and how you don't need it, but here's a new one, save dev. So a lot of times our dependencies that we use on our app, those are dependencies that in order to push our app into production, it's going to need, right? If we're using moment.js, when we take our code and we put it out on the internet, moment.js needs to go with that, right? But I don't need Jest to go with that. Right? I just want Jest to be used locally on my machine while I'm developing my code. So there's a separate sort of section for dependencies that we can list to say, this isn't an actual dependency of my code, it's a dependency that I'm only going to use in development. And that's what save dev does. So if we run this, back over here in terminal, yes, inside the project I'm working on. So I'm going to pop open this package.json doing its work. We're going to see this file changed.
Hey.
There we go. So it looks just like what you saw before, except instead of dependencies, it says dev dependencies. So it's just we have a group of dependencies and we have a group of development dependencies. That's all it is. In a world where we're using something to bundle up our code, anything that's in the development dependencies is not going to get bundled up when we ship our code to production. So this helps more advanced tooling that we might use later. That's why it exists. Today we really don't have to worry about it. We just know that if I npm install, it's going to install Jest now too. If I were just starting from this file like that.
And it's also like not the end of the world if you just npm install Jest. Like nothing's going to break.
Yes.
This means that when you
That will work
eventually
too.
publish your software on the internet, that Jest library comes along with it. No harm, no foul. But it's a good habit to get into that if it's just a dependency you need to work on the code itself doesn't need it, that's a safe dev dependency.
So now, over here, I'm going to run Jest, and I'm going to say my test folder. And Jest is smart enough to look in here for any file that is test.js, whatever.test.js, and it will run it. So I got this nice colorful output that said, test suite failed to run. Your test suite must contain at least one test. So that console.log message that I wrote, that's not a test as far as Jest is concerned. What does Jest call a test? Oh, look. Wow, that looks familiar, right? So we have a test function, and it takes a message here. Oh, yeah. Whoosh. There we go. We have a test function, so we can say test, and then there's a message here, and then there's a function that it runs, and inside there's an expect and a to be. Let's take a look at how we can use this. So I'm going to get rid of my console.log. I'm going to keep my sum for 4 and 5 here. I'm going to say test. Let's say sum can add 4 and 5. That's my message. Here's my function. This is the function that's going to get called when this test runs. And I'm going to say expect. So whatever the result of this to be 9. Woo! Yeah. Whoops.
Hey.
There we go.
We're going
So-
to agree.
Well, test pass, and even put my little message here. Some can add 4 and 5. What if we break our code? Let's say I have a bug in my code where I'm adding A and A. So this is what we would see in the output. Expect receive to be expected, right? Expected value to be 9, but it received 8. Because what did I do? I took 4 and I said 4 and 4 plus 4. So my test failed, and it shows me down here that my test fails. Once you have a whole suite of these tests, this can be really helpful. You have all these tests that prove your code works, and if you write something later that broke a previous test, you'll see the output here. So what that sounds like is it probably means I want my tests to just keep running anytime I save and make changes to my code. So I'm going to say -- watch. They are running. I'm going to come over here and I'm going to change my code back to A plus B. Hey, look, and my test just passed. And what's really great is it totally cleared all that noise. So we have all this noise here. And when I change it, it clears the screen. There's my passes, right? So in this case, I had written my sum function earlier, and I just wrote a test after the fact that proved that it works. I might say let's test with big numbers. So I'm going to copy this and say that. Actually, instead, let's say it can add negative numbers, right? So the sum of -42 and -32 should be 74, -74.
And he's not just copying the answer from the test suite, right? He's thinking about what it should be first.
Yeah.
Right. He should have put in the -7, his expectation first, and then run the test suite.
Yeah.
So do something with the big numbers and then do the math yourself. I think that's a good one. All right, so if we're going to do like can add large numbers.
You might,
Move the screen up. So,
Spell like some function.
yep, you can get errors for that too.
So 3,000. Well, let's do 4096 and 2048. So 14. Say that again. It would have been a 4, yeah. There's a 1. So that's gonna be a 4 with a 1 and a 6. Yeah?
Yeah, you should write SUDM.
He did.
I did. Was it Maria? Somebody asked what Crystal asked. Who did? Miguel? Dan? Somebody in that part of the room, yeah, said. I thought it was Crystal too. So there's somebody over there. Said what happens if you've misspelled sum. So let's try this, right? Sum is not defined. So I think, oh, where's my sum function? And then I might think, sum's not something I expected to see. I think that's a typo, right? So I'm going to go look. And look, it highlights it for me right here. Test/arithmetic.js, line 12. I go and I look on line 12. There's sum. I'm going to change it to sum. I'm going to save it, run it. Perfect, right? So we've got 3 good test cases for our sum function. I'm going to leave all of them in place. Let's say this is sum, right? Sum can do this, sum can do this, sum can do this. There's also a way to group some tests together in Jest. So I'm going to say describe sum. And then write a function here. And I'm going to move these other tests right up into that describe block. Sweet. So we have sum up here. And it says sum can add, sum can add, sum can add. So I'm going to change this to sum can add and get rid of all of this. And we'll save, run our output. Great, sum can add 4 and 5, some can add negative numbers, some can add large numbers. Beautiful. I'm happy with these tests for sum. So let's describe.
Yeah, you chose those kind of tests because you kind of decided what some can do, right?
Yes.
What would be a different scenario when we don't know what are all the options that
I think he's about to do one.
Yep. So let's say somebody. Yep. I got you.
Or just do the block above the other block.
That's a even better idea. Yeah. So I'm going to make another scribe block, and let's say we've been informed now that our calculator, in addition to summing, is going to need to subtract numbers, right? So let's say, what do we want to call it? Subtract, minus, diff.
Oh, minus.
Minus. That would mean sum should be called plus.
Sure. If you don't want to say subtract, then if you hit sum, then say
Subtract can find the difference, right?
Mm-hmm.
So there's like the 2 hardest problems in computer science are naming things, concurrency, and off by 1 errors. Whoosh.
Right over your head.
Off
So
by 1 errors.
The 2 hardest things in computer science are
Naming things, concurrency, and off by 1 errors.
programmer humor.
They're still like, what? It'll hit you later.
It'll hit you later.
Yeah.
It'll hit you later.
Ah,
Why don't you just write the code, Jason? Right?
Yes.
Copy, paste.
so I'm going to test that the difference between 32 and 14. So I'm going to expect subtract 32 and 14 to be what? 18. So I'm going to run it. Womp womp. Subtract.
So you wrote the code first. So to Maria's question, right, when you don't know what the code should do, you just start writing the code you wish you had. So Jason said, I wish I had some code that could subtract two numbers. So why don't I just pretend like that code exists? Like, what if I had a function that could subtract two numbers? Well, if I had a function that worked that way, if I gave it 32 or 14, it should return 18. So I haven't written the code yet. I haven't written any behavior, no implementation. I write the code I wish I could use. So the first behavior of that is if I give it 32 and 14, I get 18. And now Jason gets an error. Subtract is not defined. So this is the error. So the Jason is practicing now test-driven development. Write the test first, let the errors guide you. So what he wants to do is either make this error go away or change the error to something more specific. Right? Make the error go away or change the message. So what's the error? Subtract is not defined. So what do we need to do? Define it. Right? To make this error go away, we have to define subtract.
So I've imported now from the same place I was importing subtract sum. I'm going to import subtract.
Now he hasn't written, notice he hasn't written subtract. He changed the message by defining the function.
So I
Define subtract.
I didn't define the
Sorry,
function.
you defined the
I defined subtract, right? So now we have something called subtract, and the error message changed from subtract is not defined to subtract is not a function.
So now what do we need to do? Make a function. Right? Where do we put the function? Right next to where sum is. So now he's going to write a function. He's just going to write a function.
Well, I need to.
Notice you need to write a function and not use subtract.
Subtract is not a function.
Right, but it doesn't say that subtract isn't something else that's more useful.
But we use it like a function. That's why it's telling us it's not a function.
But
Right?
that's why it's telling us it's not a function, so how do we know that it's not expecting us to use it in a different way?
Because we use it, if we use this like an object, this would say subtract is not an object.
I know,
So
but it wants us to make it an object.
Okay, let's rewind a second. We use the code we wish we had. So we start with the code we wish we had. We wish we had a function that could, so we wrote it like a function. We used a function. So if we use it like a function, the error is it's not a function. So we're using this message to say, it's now time to make subtract a function. Often the error that you get is exactly the error you expect. Since we use subtract like a function, we expect to get an error that says, hey dude, you didn't make this a function. It's not going to say subtract is not an express engine, because we didn't use it like an express engine. So the errors are often exactly what we expect based on how we try to use the thing it doesn't know about. So because we use it like a function, we get an error that says it's not a function. Then to make this error change or go away, all we do is define a function. And notice that Jason isn't even going to put anything in the function. The smallest step we can possibly take seems ridiculous. The smallest step we can possibly take is just to make subtract a function. No arguments, no body. What did the error say? It's not a function. We'll just make it a function. And then let the error guide us the next time.
So
Sorry. When you added subtract the arithmetic test, first some comma subtract required, how many things can I add?
Infinite number.
It doesn't matter.
They should match this.
Just that.
We're saying from require, whatever object you
I'm
get back,
writing what I wrote on the top.
whatever require exposes,
Okay.
I only want sum and subtract. So if this arithmetic library had 1,000 methods, the only ones I care about are sum and subtract. So this might export a million things. I may only want to import or require 2 of them.
Okay. Does it have to be like the same type, like we all have functions? Or
No.
Nope.
This is just an object. It has 2 keys, sum and subtract. Those happen to point to 2 variables, also called sum and subtract. So I can use this shorthand syntax. What sum and subtract are don't matter, right?
Maybe strings.
Like I could just put up here like fooberry, right? My test, of course, is going to change back to subtract is not a function because it's a string, but I was using it like a function, so that's where so I'm gonna let my test guide me, and I'm gonna make subtract a function.
Now, now look what it says.
Subtract can so expected value to be 18, but it received undefined.
So what's the smallest possible thing we could write here to make exactly this pass? What should this function do? No.
No, you're
Smaller.
thinking too
Big.
too many steps.
Big step.
I just want this test to pass. This test.
Smaller. Put
Yeah.
18. Return 18. That is the smallest possible thing we can do to make that test pass. Our tests are passing.
So it seems contrived, right? But if we take these tiny steps, we'll end up writing better tests and better code in the long run. You never want to write code that you don't need. Like something I like to say, and I wish somebody else had said this so I could quote them, but I've never heard anyone say this. So this is words of wisdom from Jason. The best code you ever write is the code you never had to write.
Yep.
Right? So,
Jason now has a subtract function that's not really all that good.
nope.
He has, it works for 32 and 14, but you pull this up some.
Yes. Which one?
This one up.
Okay. Yep.
Arithmetic test. So he says when I subtract 14 from 32, I get 18. But this subtract function is not really general. So what do we need to do to make it more general? We add another test. So we always move forward by adding a test. So Jason's going to say, hey, if we test 5 and 4, right, he's going to write expect subtract 5, comma 4, 5, comma 4, to be what? 1. So now he's going to write, we run this code, aha. So what's the smallest thing we can do to make this test pass, right? Jason might think it's to just come up here and say return 1. And that's what we did before, right? But it'll fail the first one. Exactly. Now we have 2 tests that are opposing each other, requiring us to finally define some behavior that Maria wanted. Until we have 2 tests that oppose behavior, right? Now we need a general function that says subtract A and B. It finally made Jason, in order to do that, actually Jason took one step too many. He should have not written, he would have written this and left the arguments out, potentially. Right? Like you said, I want to subtract 2 numbers, A and B, right? And then it'll come back and say A is not defined, and then put A, and then B is not defined, and put B. Right? You're going on teeny tiny steps. Right? Boom, got it passed. Right? But Jason feels comfortable taking those steps. Maybe you're okay taking that large of a step.
There's a point you'll get to where you might say like, I know I can just write A and B here, and I don't need I know what the tests are going to tell me from experience. So that kind of happened right there. I kind of gleaned past some teeny tiny baby steps, but it's a good practice to take those. Garrett's had his hand up.
So the right side is because of jest. That's what that is.
Yep.
So there are different sorts of tests that you can install. That just happens to be the jest.
Yeah, the output and maybe the syntax that you use here, like describe, test, expect, and to be, those 4 functions are all coming from jest. So when jest runs our file, it makes those functions available, and then our file runs against those.
How did you get that into your required?
Jest automatically does that, because notice here when I ran jest, I just said jest and I gave it the folder and I said -- watch. So jest will actually require our file, and so those functions are already available to our file.
You need to describe.
You don't need it, but when you use describe, it groups. See the way the output is grouped together up top? Describe lets you make those groups. Because you might be describing multiple things in your tests, especially across multiple files. So in one file, I might describe one thing, and another file, I might describe another. But when I run my test, I'm going to see all of it.
So you
No, I installed it locally. Oh, so you're getting that because I can run it on the command line right here because the node modules bin stuff is in my path. I have a thing modified to do that. So what y'all will probably do, and this is the most common thing to do, is take your test command, make a scripts section up here, make a script named test, put your test command to run your test there. When this runs, it'll be aware of commands that are installed in the node modules folder, and you won't have to have the path set up. So from here,
Rather than say just, we'll say npm.
and this running npm test to run whatever the tests are for that project is a very common convention. So you're going to see this on all kinds of projects, is a test script, and by running npm test, it'll run your test. So what the contents of that string that I've highlighted over there might change from project to project, but to run the test for this project, I should just type npm test. That's a convention that will stay the same for every project. So you don't have to memorize like the command for 30 different test frameworks. Whatever test framework this project uses, I'm going to run it by running npm test. So if I run this here, my test will run.
So back to the testing part. This may seem really slow and a lot of work. Like you could have written subtract and known that worked. Right? We could all write. Go back here to the actual code.
Yes.
We can all write this code. We feel comfortable writing this, right? So why did we spend all of this time doing this? And it took Jason 15 minutes to do that. But if Jason were just doing this on his own, maybe that would have taken him like a minute. Right? He would have written test 13 and 14, subtract, oh, got a failure, okay, find the function, okay, make a returning team, okay, maybe do A minus B. Like that cycle would have gone really quickly. Because what he's doing is he's just watching this window, right, and looking for the error, and then doing the code, and then this automatically runs, right? Without the taking a break to speak, this part would go pretty quickly. And it seems a little tiresome to have to go through this level of detail for something as simple as subtract. But you can imagine that these things start to get more complex. Like in your hangman code, maybe you have a function that goes through one string of underscores and tries to replace the letters with the right thing. That's more complex than subtract. Wouldn't it be great if we had code that told us if that code was working? Right? You can imagine that maybe you start out with really simple cases and work your way up to a very large and complex thing.
How do you do it with word stuff, with letters?
Let's do that.
Let's do that. You want to write that function?
Yes.
Cool.
So before we do that, now that I have all tests passing, so before when my tests were failing, you notice the color in the output was red, right? Now the color is green. There's a process that we use referred to as red-green refactor. So now that I'm green, I have an opportunity to refactor my code and keep my tests green, right?
What do you mean by refactor, Jason?
I mean that I'm going to change and improve my code, maybe rearrange things, maybe even rename things.
So without changing the behavior.
But without changing the behavior, and because I have my tests, I know that my things that I'm refactoring aren't going to break my code, that my code will still work. Garrett. Yes, I will commit this. Thank you. That's a good question.
So,
how would you like Gary was saying, how would you commit this and not if you need to run every time you look at the terminal and then
you'd make another terminal.
So I could open a separate terminal, and I could run my commit message here, or I can hit Control-C, make my commit, and then start my test up again.
And would I see that? Would I see the task run in the cup like that?
No.
That's true, no,
This is only local,
okay,
right? But if I were to download, if this were a homework assignment,
yeah,
and I were to download your code, the very first thing I would do is npm install, npm space test. I would look at the test number you wrote.
Those are the first two commands for poems, aren't they?
yeah,
Except they're yarn. They're yarn.
Except the yarn.
Yeah.
To reinforce here, when we went to the docs here and we saw getting started, you can install just using npm or via yarn. It's slightly different command, but they do the exact same thing. Yarn and npm are interchangeable. They're just yarn is a npm.js.com is a company that what they do as a company is run the npm repository, right? So they provide a command line tool that comes with Node called npm, and you can use it to install packages from the npm repository. The folks at Facebook, they use all of these tools at a level that most of us never could even dream about, right? In terms of volume and performance needs and stuff. And they found that npm, the command line tool that npmjs.com provides by default, was debilitating, and it was so slow and sometimes error prone. We talked about those the way those dependency versions get messed up, that they needed to make an alternative one that did deterministic versioning and was faster. So they did. It still uses the npm repository. So the same packages are available. The yarn commands do the exact same thing that the npm commands do. They just do it faster, and they added some more features on top of it. npm saw the work that the yarn people did at Facebook, and they said, that's awesome. We're going to take most of that and pull it back into npm, which is why the new version of npm we talked about has that lock file that you don't have to say --save by default anymore. That all came from yarn. They even took some of the performance improvements. Not all. Yarn is still a lot faster. But so you're going to see references to npm and yarn. Just know that it's an alternative command line tool for typing npm, but it still does the same thing. It's still making a request to npmjs.com, downloading a package, putting it in the node modules folder. It still puts it in your package.json as a dependency. All of that stays the same. It's just instead of typing npm, I can type yarn. And in some cases, they made the commands shorter. So that's it. I did, and I pushed it, and I'm pushing it to GitHub.
So, I never went to go work on the internet since I started talking.
That's fine.
On the break, I will fix the internet. Is it back?
yeah.
Okay, good. Yeah, I don't have to fix the internet. It fixed itself.
Oh, because you power cycled it, right?
Yeah, power recycle.
Let me see if I can.
I feel like I have to do
Get
that
off
like
of
every
this.
couple of months. I just turn it off and turn it back on again. So Jason talked about the cycle red, green refactor. You will see that related to test, but particularly for the folks that do test-driven development, they live and breathe red, green refactor. They live and breathe those teeny tiny steps. Right? You'll find even the most experienced developer who's doing test-driven development will do this. If they were going to make a subtract and add function. They will define a subtract function, get an error, red, right? Red is where we write code. While we're getting errors, that's where we're working. We're not working during green, we're working during red. We're letting the red errors, I've got you, Maureen. I've got you, Sean. You don't have to keep your hands up. While red, and we're getting errors, that's when the work is happening. We're letting those errors drive us forward until we get to green. We want to get to green as quickly as possible, taking small steps. Because a small step can reveal through errors what the next step is. Once we get to green, we have a choice. We can either write more tests, or we can change our code, not adding new code, not adding new behavior, but just moving things around, organizing, right? We can't build a new kitchen drawer, but we can organize that kitchen drawer. We can't put anything more in or take anything out, but we can organize it. We can only write new code while our tests are failing. Seems really weird, right? We can only write code in arithmetic while arithmetic test is failing, because the tests are our guide.
When he
through
said,
the code.
and I just want to emphasize, when he says we can only do this, he means like if you're following the TDD philosophy, these are the rules. It doesn't mean that there's physically something preventing you from doing that. It would just mean you're breaking the TDD rules.
Yeah.
I just want to make
Yes,
make
so,
sure that's clear.
Yeah, if you're following that philosophy, then that's when you write your code. So when you go back and make the code better is during that green phase. During that green phase, you know you have this library of tests that are your comfort. Right? I have this entire backing of all these tests that are passing. Now I can freely start moving my code around. I can take this line of code, right, how the A minus B works, and I can change that to a different implementation as long as I'm not changing the behavior. As long as I keep the same behavior that's doing subtraction, I can write that code however I want and see that my tests will pass. Without that reliance on a passing test, what I can't do is make sure there aren't bugs. I can't add new features without making sure I don't break anything else. All those other things come from that. Being said, not everybody follows this TDD slide. Right? Not everybody follows write the test first, follow the error messages, get the test passing, add another test, refactor, but a number of people do. And the alternative is you write all of this code and you go back and try and write the test step coverage. I will say one thing between those two philosophies. If you write your test first, what can we guarantee is true about our main code? It works, but something more specific. You test everything. If you write your test first and the only code you write is to make a test pass, every line of code is tested.
There's another positive side effect that can happen from that as well. Can anyone guess? So what was my that's exactly right.
Yes.
You never wrote any code that you didn't need to write if you wrote a test that required you to write that code.
I can tell you from working on some very large projects, what is terrible for a code is having all of this code that nobody's using. Right? That is where projects grow, rot, and die. And all of the code
Big
that
rot.
nobody's using. Yeah. So you don't want to write code that no one's going to use. Right? You don't want to write anything in your calculator that you didn't need to have a post to Facebook feature in your calculator if you're not going to use it. Right? So why did you bother writing? So your test driven is going to make sure every line of code is tested, and you've only written the code that you actually need. And you know that as you add new code, it's not breaking old code. It's also going to be easier to test that code because you wrote the test first. It will happen to you, maybe not here, but it will happen to you on the job. You're going to walk into a code base that's thousands of lines long, and your job is like, hey Angel, your job today is to write the first test for this code. Holy smolies, where do I even start? Because once you have a big pile of code, right, and it's all intertwined and all your functions are working together and your express posting gets are all doing things and they're redirecting, like how do you crack that open and start writing tests? It's very hard to write new tests for a large existing code base. It's probably one of the worst things to do.
I think we should take a break
Yes.
before we do the hangman. But one thing I also want to add is, now I'm totally drawing a blank. I think I want to add was
A little philosophy thing.
yes. It is. God, wow! It just totally disappeared. I'll think of it in a second. Don't wait for me though, because then I won't think of it.
So let's take a break, then when we come back, let's go back to, well, no, don't run away just yet. Let's come back to, whose question was it about Hangman? Avi's question about how would we do something like Hangman. So here's a bigger problem, bigger than the add and subtract, which is I've got all these strings of underscores and I've got a secret word, but I guess a letter, how do I replace the letter in the right spot in the word? Right, so now I don't have underscore, 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 I have underscore, underscore E, so I guess E in the word the, right? That seems like a bigger task than just adding two numbers. Where do we start? How do we know what to do? To Maria's point, how do we know what behaviors to have? We'll see how that works through driving the tests.
Because I don't know. Like I don't know what the code's going to look like to do that.
Yeah.
But I know how to start writing the tests because I've practiced doing this sort of thing with writing tests before,
So we've got a blank slate. This is how to solve that blank slate. Where do I get started from?
and I remembered what it was that I was going to say. So, from a practical point of view, how much code should you test, right? There's code out there where, like Gavin said, there's no test written. The best thing would to have all of your code tested. Somewhere in there lies like a happy, realistic medium. A lot of times when I write code, interface code, like the code that tests if I click on a letter, does it call the function that calculates the hangman and shows me the result? That test can be a little bit difficult to write. It can also be brittle because if I change my interface at all, I have to fix that test. So a lot of times I might write code, unit tests like this that test the business logic of the app really, really well, right? So I want to make sure that given a set of numbers, the letters the users picked, is my output correct, right? The word that we're going to show them and how many points do they have remaining, right? I'm going to make that correct. And if I can make that correct, then I can just make an interface to that and set up all the event listeners and click it on buttons and stuff in my interface. And, you know, if that breaks, like, we'll just do user testing with that, right? We've got a QA team who will click on all the buttons before we deploy to production. But I've also got unit tests for the business logic that I know for sure that works. And as long as I put my interface on top of it, I can live with that. Like, me as a professional developer, like, that's a happy place for me. I've got unit tests that verify that the business logic is correct, and I just have to make the interface work now. That's kind of a happy medium for me, who I spent large portions of my professional career as either a solo developer, like I'm responsible for everything myself, or I'm on a very, very small team with just 1 or 2 people. Sometimes just like one other person who's like a junior. So I don't have the time to realistically devote to writing 4, 5, 6 times as many tests as I do code. Like, I also need to ship, right? You gotta ship it. So it's a spectrum, and somewhere on it is better than no tests at all. So that's what I wanted to add. Cool. Let's
Great.
break. When we come back, we'll write that business logic I was talking about for Hangout.
What time, Jason? 11?
11?
No, so we'll give them a 7-minute break. You're cool.
That is pretty cool. How about 10 after?
10 after. 10 after 11.
See, I say 11, and it's really about a quarter after.
Yeah. That's because that's why you do the bell and the lights.
Yes.
Jason, I still couldn't get the just to work. Trying to figure out, like, so I've got that scripts, and then I did.
You should try just writing in that.
Oh, here? Thank you.
It's a happy side effect of TDD not needing to console.log.
That is the happy side effect of testing of any kind.
Right.
Yeah, not having code littered with console logs, because your tests are essentially replacing that console logging style, without having to like put debuggers and console logs everywhere. Try and let the tests drive everything, because console logs are not repeatable. Right, some human has to look at it. Tests are machine repeatable. So the more we can make the machine do on our behalf, the better off our lives will be.
Yeah, and you have confidence knowing what you expect is what you're
Yeah,
actually doing.
we have 3 tests, but large projects will have tens of thousands of tests.
Yeah.
Right, so no way that one person through console log or any other means could check 10,000 things in any project in any reasonable amount of time.
So
But our test suite could run that in like 4 seconds.
with the Tampa Ruby degree, I'm sure you've had a ton of Ruby. So did you ever meet a guy who's actually from Citrix? I think Will Green.
Mm-hmm. I know Will real well.
Yeah.
Yep.
So, I've talked to him some about it, but he's from the same city I'm from.
Mhm.
So I think he works for Mandiant now.
Yes, he worked for somebody, and then like a security company, and they got bought by somebody, something.
Yeah.
Now they're owned by something.
Firelight
Yes.
was bought by Mandy,
Yes.
or vice versa.
Yeah.
And prior to that, he worked at the company that I worked for before I came here.
Ah.
So I knew
Yeah.
he was a botnet guy.
I remember.
Yep.
A part-time Ruby guy, full-time .NET guy.
I run into that guy everywhere. If I go out to eat, I almost always see Will.
Yeah,
somewhere.
you have to say hi for us because we don't get to see him very often down this parts. Doesn't make it down to.
I'm surprised he doesn't come down for some of the Ruby meetups.
Yeah, I think it's so far, and it's family and time. I totally get. I would not drive up there for meetups.
Right. Well, no. Who would,
Yeah,
I'd
but even
rather
if like
drive out there to see families.
yeah, like even if there were like a ton of meetups up there, I don't know I would drive that far. So I don't give him any slack about not coming
Well,
down. as
he
far.
worked next to the guy that told me about Vineyard.
Yeah.
Yeah, it's the guy Mike, which you may have met him in passing. but
Yeah.
Not probably wouldn't be as familiar with.
Yeah.
But yeah, so they worked at the same company together, and then Will left to work. For
I remember. Yeah, I remember the guy. Yep, because they came to meetups a couple times together.
Yeah, it's all. Yeah, he's the one that suggested the name.
Yeah, I don't blame him not coming around as much, but tell him hi for me. We'll just see you next time. Yes.
So, can I use like generic? Like something that that's what I was thinking. No.
Yes, you're gonna see it when we do this.
So they are like some kind of stages to start to see if you should. That's not a bad idea.
I think it's something we started. If I was looking at data, I would start with the simplest possible. As simple as possible. As simple as possible.
Okay. And then work your way.
Because you have the same blank slate problem. What is the simple? What's the simplest thing possible? What's the simplest thing that you can possibly? What's the easiest word? Easier than that.
No.
Easier than that. H.
Okay.
Word A. Word H. So if my word is A, I have one blank. When I write a function that changes this A to this word to an A, you find this is A. I should. That's the first thing I know. I will try to figure whatever the problem is. What's the simplest version? Right? What's the simplest version of my word? That's possible.
So that will be like my rule. Start with this.
Simplest possible. Simplest. Like, what was something simplest thing? A is. Right? When you drive to the simplest thing possible, that's when you do the start. And then we're going to build more. Good idea.
Yeah.
I mean, I've already like 120 ounce coming in. That's
I didn't know that I could save my bonds. So every time I open it, I have to start over again. Yeah.
Where you just yarn resetting?
Yeah.
Yeah, just don't do that.
We didn't know, so we had to do it immediately. And then we didn't figure it out. So we
But that's good, that's good practice.
we didn't mean too much. We look at, you already know this one. You already know this one. Go. And then, like, we don't know.
Such a brain about
Yeah, it's really bad. We know it by heart.
Every time you reset it, it should reset the file, or it's like on there.
What is date equal? Because I cannot figure that out. Even online, I haven't found anything on it.
Yeah, well, we'll talk about that because that might want to not be equal in testing. It's because a JavaScript object and like an object with like key A equals 1 and another object with a key A equals 1. Would you think that if you did triple equals they would be the same? Well, yes. Would you think? Not you know. But would you think?
I would.
Right, they're not, because they're two different objects, right? You need the simple types, like a number, like 1 is triple equal to 1, yes. But a complex type, like a compound type, like an object, or an array. If you have an array, with the numbers 1, 2, 3 in it, and you ask, is this equal to another array with the numbers 1, 2, 3 in it? They are not equal.
So why names on
Here's why.
Yes.
In JavaScript,
Yes.
the string Gavin, if you say this variable is a string Gavin, and this variable is a string Gavin, it's the same Gavin. Those strings are the same strings. JavaScript, once you create a string, there's only one copy of that string. No matter how many places you say it. Once you have the number 7, if you make another variable 7, it's the same 7. There's not 2 different 7s in JavaScript. This 7 is 7, and that's 7 is 7.
Like a duplicate.
They're the same ones,
Okay.
not a duplicate. The duplicate would be the same thing, but 2
Yeah,
different
yeah.
ones. It's the same 7. But 2
So-
arrays
so
are
what-
not the same array.
So why would I have 2 strings if they mean the same thing?
Here's the way to think about it. Can you change a 7? Can you make the 7 mean something other than 7? 7 is always 7.
No, if you subtract a number from it, you just get a different number.
Different number.
4,
Yeah.
right?
If you take the
4 is
name,
always going to be 4.
if you take the name, if you take the string Gavin, and you add a character to it, you have a different string. Right? You can't change any JavaScript. You can't take the A in Gavin and make it an X. That's not allowed. Because that Gavin is Gavin. Right? So those variables always fall immutable, unchangeable. What's true of an object? You can totally change that to A and A out. You can take that object and do dot A equals something else. So an object is immutable. Right? So once they're immutable, then you can't compare them. These are 2 different ways.
So what deep equals does, to answer your question, is it asks the question, are the values of this thing all the same? Right? So if I compare the array with the numbers 1, 2, 3 in it to another array with 1, 2, 3 in it, and I just say, are they equal? No, they're not. They're 2 different arrays. Are they deep equal though? Then rather than looking at the array itself, it looks and says, are my values the same? And if the values are the same, then they deep equal each other. So if you have an object with the key A and the value is foo, and you have another object with the key A and the value is foo, those are 2 different objects. But if I ask if they're deep equals to each other, then it looks and it says, do both of these have the key A and is the value in both of them foo? Then there is.
Everything in those objects have to be the same.
Is there nothing in this object that's different or not present in the other object? Both ways. Are they the same? Other than being 2 different objects, are they otherwise the same? Deep equals will ask that question. Because an arrays can have arrays of arrays, and you can have objects that have keys that are arrays that have objects in them. And deep equals will go all the way down and look at everything and say, are these the same thing all the way down?
So Jen, 2 messages.
Okay.
I think that was database. I'm not really sure what they're asking me. You guys think that one's, I'm not really sure. So I think that is how to read the question and understand what is it they're asking me.
Yeah.
And then,
Listen, I set those up to use that testing framework, but I didn't write all the tones myself. And there's a couple in there that I think are a little bit
too hard.
not that it's too hard, it's that the way that they're worded or phrased is not that great. So I either want to fix those or just remove them and replace them with something that's similar.
Don't tell Javi, but I convinced him that we were both very nice. Like, we not getting this.
It's not that. Yeah, those drawings use another testing framework called Ava instead of Jest.
Yeah, when I looked at Ava, I just said,
Right there.
Not a number of great.
Ava to Jest.
Yeah.
It's a weird. Sarah, can you just please review this, that those are the steps of setting this up so that way I spend less time.
That's us.
Because you're not going to make any new directories to all new .js.
No, but it's gonna be a name, not GS.
Yeah, but you don't use Maker.
I guess it's
Yeah, it's very,
You don't install
yeah,
Yeah.
yeah. about things no matter what.
If you install a package, it'll make it back into the lock.
It makes sense, I know. But I don't
The
know.
lock file is basically just ignore it, don't even worry about it.
Yeah, but it's something that's there, and then I'm like, do I install it, or just?
No, it'll make it, it'll present itself in the game, and its contents will change automatically.
Right.
Just ignore it. Just keep it in your git repo, like committed and everything, but don't worry about it.
Yeah. I like finding holes. Alright, so, yeah, he's better than me, so that, I like, just not minutes. There are worse things. I get developers that are hired specifically just to do Every time you said that, I thought you said it. I don't know if you want to do that. Yeah, that's probably not a job. No judgment. I'm hoping you. I knew.
I was up for like 2 seconds. Call me back.
Yeah.
Yeah,
That's how she said it.
Way
Good.
too good for
So one of those guys have
We were all on that spot though. We had rules here and nothing to break into. That's why we were doing like. I got my neck was yeah, but it's not working.
this will be
Some bugs. That's why I made a face. I was like, bugs.
given this
Why do you
word,
love them?
this array of,
No, it's okay. I respect.
given a secret word,
So I don't know if you saw me make a face.
An array of
when I
guesses.
said
an
that.
array of guesses.
Here's underscore underscore B underscore underscore C.
Do you?
Yeah, most of them are writing the keyword strings, the hidden word.
No, I just feel like I'm here to get it on. It's ridiculous. It's like I want so much. Yeah, you're not. That's why I didn't even on my idea. Yeah. There's no lemon juice.
This like working coming on.
We'll make for
The way I've always approached that because I don't care. It's like the only person that's cheating and doing that themselves, and that's the problem.
I kind of fall in the same trap.
I see instructors are getting all worked up about like pictures and why do you care? Like this person's here, like they made this experience, and that's what they're making of. I just let them.
Yeah, I know the only thing about a downside, a lot of people do that right down to the workforce. That fucks up.
So that does. But I also think that like,
They tend to self-edit.
yes. They won't, for those of the people who don't finish their own project, or like,
I think that was well, it wasn't before my time. I feel it was just so
that's why it's crazy. Not a lot, a little bit. You should
the reason we had here when I was graduating
have an intro to software.
and it was Linux,
I'm also like,
and I can't wait to get it.
that's some magic. Goes back to tables. I think 24 is I would call it between 20.
Right, yeah, 20, right, 24.
Yeah.
Like at least 18.
Yeah.
24, no way.
Yeah.
It's 33.
Yeah. Or 30 now, but started out talking about testing, and we showed some examples of writing some tests and a test framework. And along the way, we came across this question of like, how do we get started? How do we know what behaviors to add or to test? And we showed a simple example of sum and difference, and how we asked the question, what do you do with something more complex like strings? We thought maybe a good example to show how we would drive both behavior and code in a test-driven style would be the part of a hangman that generates the underscored version of the match, what part of the word you've matched so far, right? So that's what we're going to do interactively up here, starting from clearly a blank set of hangman tests. Right? So we'll always start with the blank slate, which is, I think, at least for me, is like the most fearful spot, right? I have nothing, where do I even start? So Jason's going to run the test suite, make sure we're at least, okay, well we need a test. So, right, if I want to change this here, why don't we just make one test? So we're describing the hangman. And Jason's going to write one test. Maybe this is just our hello world test. I was thinking more even without an expect. Just why didn't you just write test hello world? Is that enough for it to pass? All right. So this is. So are you trying to copy along? Okay. So you're welcome to try, but Jason may go a little fast. So right, the first error that Jason got was you need at least one test. How do I change that error? I add one test. Right. Even from the very first step, I'm going to try and take small steps. And then Jason and I are going to check each other to make sure we're taking appropriately teeny tiny tests. So I think that's the small thing we can do. Now we have to think about the hangman game. All right, so I had a conversation with students beforehand about what's the simplest hangman game we could think of. And the student said the word hello. I'm like, no, actually I think there's a simpler one. He said, yeah, we came up with like a letter H or the word A, right? I think if I were going to start with testing hangman, and we just mentioned the base of this, that I might start with the hangman game of just a single letter. So when I look at a problem like this, I'm not yet worried about long words or words with double letters or words with letters I'm not going to guess. I'm literally going to start with the simplest hangman possible, which is just one letter in my word. Right? So Jason's going to start with, if we call a hangman with A, what we should get back is underscore. Cool. I think that's probably the simplest thing we could possibly do. The word we're trying to guess is A, and if we ask for hangman, we just get back an underscore. Hangman is not defined.
I think we're gonna write it the other way, to hangman, like space and then to A, not the other way.
No, we're saying if we have the secret word is A, right? If the secret word is A, then our hangman display is underscores. So
this is what we're displaying. This is what's on the Jeopardy board.
Okay.
Yeah. Right. So what we're trying to compute is the Jeopardy board. That doesn't go on the left-hand side. That's what we're going to compute. So the given, the setup is over here. What we generate should be over here. We're saying if we call hangman with the letter A, and we're going to add more things to this eventually, what we get back is the display underscore.
Is there a way that we can put that with it?
Yep. Oh, that's how I just renamed that.
Why do we need it?
To get it out of the output.
Oh, gotcha.
Cool.
So it said hangman is not defined, so let's define hangman.
So what if the test hello world what are you gonna say?
Well, Jason should probably change the hello world name. The hello world we ran first was just to make sure our test framework was set up. So now we need to say like single letter. Yep. So if we get a single letter A as our secret word, then underscore is our thing.
So hangman is not a function.
So the first error was hangman doesn't exist. Then he said class hangman.
So I'm going to go ahead and require hangman. I still have the same error. Hangman is not a function. So I'm going to go ahead and go in here,
Make hangman a function.
make it a function, and get it over to the other file.
So all we're working on is trying to make hangman a function, because that's the error we're getting. Exports. Okay, cool.
What was it?
Yep.
Yeah, it is exports. Okay.
So finally we made hangman a function. We didn't do any work with the function, but we don't know yet. We're just working on making the function. Now the test said, hey, we expected to get an underscore, but we got undefined because there's nothing in here. The simplest thing we can do is return underscore. Hey, it works. Awesome. All right. So now our hangman program works only if we give it a single letter and expect to get back an underscore. Right? Not very useful yet. Let's keep iterating. Now that we're in green, now we can add more tests or refactor our code. So Jason's going to add a second test. I think there's a simpler thing to work on, maybe. I don't know. I think we could go with a more simple word, but we haven't introduced. I go with a simple word. I'm fine with that. The other thing I was going to suggest was we haven't said like this is the secret word, but we haven't guessed any letters yet.
We'll be in the next test.
Yeah, I'll go with that.
So I'm going to say, let's say we want,
So if that's the single letter, you're going to go for a multi-letter word.
yeah,
So he's staying on the same path of just simple words. And rather than have a single letter word, now he's going to go with a multi-letter word. This is going to push us away from just being able to return underscore. So if you expect hangman of that should return what? 3 underscores. Should be underscore, underscore, underscore. Yeah. So now clearly our underscore here is not enough. So we've got to do some work. We do the simplest thing we can think of to make this work. Yeah, so we do 3 underscores, then this test will fail. So clearly we need to be able to differentiate what word we're working on, so Jason's going to add an argument. Because now we need to know, are we working with a single letter or a multiple letter?
I was just checking.
Ah, okay. Hey, so the simple thing you can do is just generate as many underscores as there are letters in the word. Right? So if you get an A, you get back an underscore. If you get the, you get underscore, underscore, underscore. Yeah? So easy. So far, easy.
You can put some line.
Yeah.
Yeah.
So that's what you use for, right? That's what you define a single word, is to make it treat that after breaking it.
Right. So in the beginning, we didn't even need this argument because we were just returning a dummy underscore. Now that Jason added 2 tests, now we need to be able to differentiate, well, are we working on a single letter or a multiple letter word? Aha, that means we now need an argument here. And he's going to use that argument to repeat the underscore a certain number of times.
So if I didn't know that strings had a method called repeat, I would probably be looking in MDN for a way to do something like that, and I might have encountered it there.
Yep.
Which is, in fact, what I did once. And I just happened to remember that it was called that. fact, I wasn't sure that if it was this or if I was just thinking of Ruby.
Yep. I could also think that maybe you would have written a for loop and concatenated. That's totally fine. Whatever you think the simplest way of doing that is,
If this was Ruby.
yeah, that's Ruby, you do that. But it's not, so you do this. Right? So maybe we try a couple, maybe we try a really long word, right? Maybe we try a blank word, right? That would be topological case. Maybe we try a long word. I love the musical background we're getting tonight. It's really good. Supercalifragilistic.
One second.
How many words?
Oh no, I'm gonna ask Google. Did you mean? It's Cali, like California.
Califragic. Right. So maybe what he's going to do is what I would do is copy and paste that and just replace. Well, I would have copied if I were me. I would have copied this over there.
And then replace each character
Yep.
with an underscore.
Yep. Just to see if I did it right.
Like this.
Underscore.
Oh my god.
Underscore. If I really wanted to know, right? But if I were really testing, right, and not like the danger is if you rely on the output of your code to test your code, right? You're cheating.
Yeah.
And you could be setting yourself down a false path. So it seems weird that you would copy and paste that and take the time. But if I were writing production code, I was getting paid for it. That's exactly what I would do.
This wasn't really what I really expected. This is what my code produced.
Right.
Right.
What I expect to have happen is that I would get as many of these underscores as there are letters. The only way for me to know is either for me to go 1, 2, 3, 4, 5, 6, 7, 8, and then do 1, 2, 3, 4, 5, 6, 7, 8, or copy and paste that and replace every one of those letters with an underscore. Well, we're doing a long word on purpose, right? But the test is a long word, so I need to use a long word. So I need to take the time to make sure my code still works for a long word. Anything else is cheating myself.
Can you delete one line, like one space, just to see what the error is?
Right? Expected to get underscore, 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 but I got underscore, underscore, right?
Okay.
You also put the side panel to yourself some more space. Right? So we have a single letter, a multi-letter, and a long word. Right? And we know that we have the right number of underscores. So where do we go from here?
Oh, include some guesses.
Yeah, I think we need to include some guesses. So my feeling is I would again start with the simplest case. Every time I venture into a new behavior, I want to start with the simplest case. So we're going to do a single letter with guesses. So we're going to go back to our A. And then we have to say, what's the simplest guess we could make? It's probably also one letter. Then we have to do, are we going to guess the A, or are we going to guess not the A? All right, so the simplest word is A. The simplest guess is just one guess.
Oh wait.
And then are we going to guess
Single
A or
letter
not A?
with no guesses.
Yep. All right. So you also work on putting the new test at the top of the file.
Yes.
In the back.
Yes.
Sorry, can you repeat what we
Yeah, so now we've tested the fact that if we have just a word, we get back as many underscores as there are letters. Now it's time to make guesses. Right? Because hangman is not just the word and the underscore, it's the word and the guesses and the underscores. So Jason's going to now come up with another test that says the simplest case is a single letter word, but no guessing. So now you also notice that he's changed the signature, the number of arguments to hangman. He's had to introduce a new argument to hangman to get the guesses in there. And he's saying, if that's true, there should still be underscores, and guess what? Our test still passes. Did we expect it to pass? Yeah, because that's what it should do. So sometimes you're going to add a test for a new behavior, and your code's already going to support it. That's great. I got code for free. Now Jason's going to say, hey, a single letter with a guess that's wrong. With a wrong single guess. Right? Here's a new function. you're gonna say expect hangman of A with a single guess of string A.
You put like a P or
Yeah. you do A. All right, and what should this be? Still an underscore. Let's save that and run it. Hey, it still passes. This is awesome. It's like the code's writing itself. But we're about to prove that's not true, right? So he's going to take this pass, right? Now he's going to do it with a correct guess. Oh shoot, failure, right?
Wow.
We expected to get back now an A, because that matches what we got back an underscore. Now we have to write the simplest thing that can make this work.
why are you receiving an empty one? Like if you already done this and
Right, because we're saying if the secret word is A, and you've guessed one letter A, what we should display is A. It doesn't hangman, right? There's a row of matches, right? And we haven't guessed anything, we should show an underscore. If the word is A, there's a single blank place waiting for a match. If the user guesses A, here are the guesses, then what should you show? A. Because that A fits here.
So why, if it fits there and that makes sense, you have an error?
Because what is our code returning? Just
Oh.
underscores. Our code has no logic yet.
Oh.
So we finally expected an error. Why did this one work is because, hey, no matter what we send in, we're always going to get back underscores. I think we're
Are you assuming that in your later code, you're just going to go into array, that's why it's
Yes. So here's the other thing. Jason has made a decision about how he wants the code to work. This is another nice part about writing your test. First is you make a decision as the user of the code before you have to be the designer of the code. So we wear two hats as we write code. We wear the hat of the person who writes the code, and then over here we wear the hat of the person who has to use that code. Right? It'd be great if we worked in a situation where Jason would always write that code and I just have to use what he wrote. Right? Hey Jason, I need a hangman function. No problem, I got you. Let me write it. Okay, now I can use it. Hey Jason, I need a function that does this. Okay, I wrote it. Now I can use it. But often we're both sides of that equation. So it's nice if we can write the code from the user's perspective, the person who's got to use that code, in the style that we want. So Jason decided, as the user, what I want is I want to be able to send you the word and an array of all of the guesses. And what I want back is what the hangman display should look like.
Probably.
I have a 40 so that's the same.
Oh, I have a.
Yeah, it doesn't matter what it is.
But I should still have good English.
So are you just refactoring the test a
Mhm.
little bit? Okay. Right. So he says, hey, if I call hangman, the secret word is A and the guess is E, I get back nothing. But if I finally say my secret word is A and I give you a single guess that's A, hey, that matches. I should show it A. Right. So this idea that we keep adding the simplest test we can think of. Sometimes those simple tests are going to pass because our code was already ready for it. But we should push to the point where we get a failure. Right, so we said A with nothing, hey, that worked. A with a wrong guess, ooh, that worked too. Finally, an A with a correct guess, now our code doesn't work. Now we've got to return to the hangman code and make this code work.
What happens if I want an error and I cannot fix it, like I'm stuck, can I just delete that and try something else? Or how would I try to like
It depends on what you're doing. It may indicate that you took too many steps.
Okay.
It may indicate that your expectation is wrong. It may indicate that you're not following the error close enough. You can roll a step back and try and go forward again. Yes. But usually try and chase down this either error or unfulfilled expectation. So Jason finally now has to deal with this.
Actually, let's dial it back a bit. Let's say I have not decided to use an array. I'm just going to pass a string that has my guesses in it.
Okay.
So this would be an empty string. This will just be the string E. And this will just be the string A. There we go.
Everything still fails.
we're at the same point. Everything that was passing still passes, but this one still fails. So what I have here now, I need to deal with my guesses, right? So here's my guesses. We'll call it guesses. So what's the simplest thing I can write here to make this test pass?
So we have to think about the cases that were passing, and then the introduction of the case that wasn't passing. Yeah, they'll give me some kind of condition.
Letters equal.
Say louder. Something on. If what?
If letters equal.
If the word is exactly my guesses, then return the word. Otherwise, return the underscore. If this is exactly this, right? Return the word, right? If this is exactly this, then return the word.
That would feel for a 2 hours.
But let's say
Now we keep
test
working.
a short word with correct guesses. Hang on.
Yeah, your team.
All right.
Then I do a short word.
And let's say I guessed TH and E, right? Okay. That works. But what if they were in the wrong order? Or let's say we didn't guess all of them.
Yeah, you with an incorrect guess. So you guess T, H, and X. So we should get back TH underscore, right? If the word is THE and we guess T and then H and then X, we should get back TH and underscore. Oh no, now our logic really doesn't work. Because we can't just return a word, right? We're saying if the entire word is correct, return the word. If the entire word is incorrect, return underscore. So now we have this middle condition where part of the word is correct and part of the word is incorrect. So now we really have some logic to write. And so you notice, like, how many tests do we have so far? Like 8, 9, 8 tests.
7,
total.
8 total.
8. We've written
It's down
8,
at the bottom.
We've written 8 tests so far, and we have not yet written the logic of hangman. Or about to.
So this would be this string would be the list of letters that you've guessed just as a string. So if you guessed A and then E, the string would just be AE.
Yeah.
That makes sense?
E and then A would be EA.
Yep.
Right, so you could have written this as XTH as well.
Yep. Maybe let's do the simplest case here where you just guessed X.
Okay.
Then the output would be this, right?
Now guess X and T.
Or E. I'm going to do E because I think E is a good first guess. With a single correct guess. Womp womp. Okay, so here we are. Yeah, so we have 9 tests. This is what we're... at this point, we really have to think about some logic now, right? But I've got a bunch of tests that make sure that if my logic is wrong about all these other things that should be true, I'll know that already, right? I've got tests that all of them are already verifying things that my code up until now solved correctly.
But you're just focusing on making this work,
I'm just, yes.
right? He's only worrying about this test. He's like, I need to make this test pass now, keeping all the rest of this working. He's just focusing on this situation now. And he realizes that this code is not detailed enough. He's going to change this implementation to deal with this new situation. The rest of the test will bark at him if he messes up. Or he has
I have a question. He's trying to find the guy. How about if you have as many guesses as you like? So you would at the end find whether
That's not, that's another behavior we're not worried about yet. So that's the problem that most testing people have, is they're worried about the thing that happens later. What about this, and what about this, and what about this, and what about this, and what about this? What that leads to.
Put a pin in those thoughts.
What that leads to is that code we talked about before, where your code has all this code that's not being used or isn't needed. If we write the test one step at a time, we are never writing code that we don't actually need, but eventually we're going to write all the code we need because we're keeping track of all those questions, and eventually we're going to write a test.
How many people have made some variables or named some empty functions in your file because you know you're going to need them later?
Yep.
Don't do that.
Yep.
Oh, my mic was off.
Yeah.
Yeah. Anyway, don't do that. Don't do that.
Yeah.
It's like there's nothing wrong with having done it up until now, just because like that's a thought process, right? And you're thinking ahead a little bit. Keep those thoughts in your head that you need them. Maybe write them on paper on the side when you're planning, but in your code, you don't need them until you need them. In fact, we have an acronym for that, YAGNI, which is you ain't gonna need it until you need it, right? So
the factory that Hangman has a certain number of guesses and then you're done, we're not even worried about that yet. That's a thing we're going to add later. And what's nice is when we get to that stage, we have all these tests that tell us if the core part of Hangman still works. So we're always just adding a little bit more, even that little bit more is adding the new requirements of the thing that we're doing.
So what I'm going to do is write a for loop here. And I'll make a new word or is it going to take word?
You cannot.
I'll get a new word back.
Huh? You think you'll be thinking out loud?
Yeah. No, yeah.
Okay. So you're going to make a string and then build up your output one letter at a time. You notice JSON has to get rid of this implementation. It's no good anymore. He now has to do a dynamic implementation because this is not enough logic. So he's going to go through the word one letter at a time. He's going to say, if something, else something else. If this condition is false, he's going to append an underscore. This is the case where the letter did not match. In this case, the letter did match. He's going to output that letter.
So what's the condition I need to write right here? So if something's true, I'm going to push that letter into my output. Otherwise, I'm going to push an underscore. So what's the question I need to ask here?
What's it in English? Don't try and think of it in code. What's it in English? Yeah. So a little bit of combination of both of these. More detail. Not the guess is correct. What would be true about this letter if you want to append it? Where would we find it?
Yeah. So I know I'm going to have to deal with word I.
If it's anywhere, if the letter you guess is anywhere in the word.
Yeah. If this
Flip around what you just said, Jonathan. If the guesses include this letter.
If this guesses include the letter or I, then we want to output it. It's not includes, it's included. Oh, maybe it is includes. You're right, it is includes. Because some of your functions don't have guesses.
Yeah. Yeah. So here we go.
But I think there were some questions before this, Jason.
Yes.
There were some. I think there was some like what on this, right? Yes. Okay. Yeah. So before we dive into the next thing, let's finish the logic before we go through why it's failing. So we could use for each. There's like I could think of like at least 5 or 6 different ways of solving this. I did it with a student beforehand with math.
Yeah, in fact, when we refactor this, I'm going to turn this into a one-liner with math.
So what he's doing
Once all our tests are back.
Jason says, I'm going to build up this new string of either underscores or the right letter one at a time. So that means I have to go through Word one character at a time. Maybe it would help, Jason, if you extracted a local variable here, or a constant letter. And let that be word of I. And then here say output equals output plus letter. So this is a habit I like to do, is extract the variable for the, right? If I'm going through the letter, I'm going through a word one at a time, right? then I get a letter at a time, so letter is the word top. Right? Back to like week 1 of JavaScript doing forms. So I'm going to get the letter, right? So I'm going through the T, H, and E. When I get the T, how do I decide if I'm going to show that T or not? Right? I think Crystal said it. Did I guess a T? Right? I'm going to show the T if I guessed it. Where are my guesses? Here. How do I know if that T is inside of these guesses? If the guesses includes the letter. As I go through this word 1 letter at a time, if my guesses include the letter, then I want to add that letter to the output, right? The T goes in. When I get to the H, I ask, is the H in those guesses? It is not. So an underscore goes in, or placeholder. Right? When I get to the E, is the E in the output? Yes or no? Either add the E or add the underscore.
So these cases all passed, including the one we just had, but the first 3 tests we wrote early on are now failing. Let's go back and look at those.
So yay, the test we were working on passed, but one of our other tests failed.
So I did something where I refactored a lot of these to be a little clearer here. So I'm going to go ahead and do that. And then let's change these back to match here. So I had that.
All he's doing is pulling out little variables.
We said the, and it was 3 underscores.
He's not changing the code, he's just making it a little bit clearer for us to see. Well, that goes to the next code.
Yeah. Yep, you're right. Hang on. There we go. That, it's Alfred
Which has a clipboard screen built in.
in the Power Pack.
Yes.
There's free apps to do that though.
Yes.
Alfred is free. The Power Pack is not. That particular feature is a feature of the Power Pack of Alfred, but there are free apps that do just clipboard history for free. Alfred does more than that.
So you just refactored this code to be more clear about what the receive is.
Yep.
So, but these 3 tests are still failing.
So what's the difference between these first 3 and the later ones? And here's
The later ones have 2 arguments.
yes. I introduced a second argument for guesses that my original 3 tests did not have. So I have 2 choices here.
Those tests didn't have it because at the time you wrote them, we didn't need it. So your old tests still need to be curated. Your old tests still need to be updated. They don't get written once and left alone. As your code evolves, you're going to have to revisit your old tests and bring them up to date with the new code.
So I have 2 choices here. I can either say that I always need to pass a second argument, or I can have a default value for guesses. Which one's the correct choice? I guess it depends on how you expect your function to be called. Do you ever expect it to get called without a second argument?
In this case, I would say no.
Yeah.
I would say you always have to have the word and the guesses.
So,
It doesn't make sense to have a hangman game without any guesses.
well, you have an empty guess set.
Yeah, without even an empty guess.
Yeah. So if I pass our empty guesses here, there we go. So let's try a more complicated example, going all the way back to what we thought originally might be the first thing we start with, and say, hello. So if the word is hello, and the user has guessed E and L, then I should expect to see underscore ELL underscore. Do we think it's going to work?
No, it does.
My implementation is done, right? Now we thought like, oh, I might have to handle double letters or something like that, right? And I might have been trying to think about how I'm going to handle that in my code. But because I started from these very simple test cases, and I baby-stepped my way through, and I let the test failures guide me, I got to a working implementation, and then when I went and I added that thing that I thought was going to be hard, it already works, right? Because I let the rest of the test guide me through the process, and lo and behold, the test almost solved the problem for me.
Because all we did is let the error guide us and think about what the next smallest, most complicated case could possibly be.
Now, it's possible I could have come up with a solution where this wouldn't have worked, right? And I would have had to have gone and revisit my code. That's fine. And you'd keep stepping through and eventually maybe come back and refactor. So at this point, I've got tests that prove our hangman algorithm works.
Come here. Why are you looking?
Okay,
And push with something like that.
it's done. So here we go.
Get rid of that.
I'm going to get rid of this comment. We don't need this. That's the old implementation.
So that's a thing I see a lot of you all doing that I haven't when I'm grading your homework. Getting too far on you yet. Please don't leave around old implementation.
I've also started commenting on console.logs. If you're turning in code with console.logs still in it,
Yeah.
in the past, just kind of ignored it, but I'm going to start commenting on that when I see it.
It'll be an assignment or a task or a to-do that I'll add for everybody, which is to go back to all of your code and get rid of any of your commented on code and your I tried this, that didn't work. Your
Now-
code should always be clean without like past attempts commented out.
Now, commented explanations of the code that's there is fine, but commented out old code that didn't work or code you think you might need later, that can go.
That should go.
That should go.
We want to show nice, clean examples.
So here's the solution. It's all well and good, except it's a little bit of a lot of code for something that I know from my experience could be shorter and could use a functional style as opposed to this style. So what I'm going to do is, now that I have 10 tests that verify my algorithm works, I'm going to see if I can refactor my algorithm a little
So
bit.
you're going to change the implementation of the code without changing its behavior. The new code has to do exactly what the old code did, but with different implementation. So he's not allowed to add another argument. He's not allowed to change the order of the arguments or what they do or what this outputs. It has to take in the same thing and output the same thing, but do the computation differently. So he's going to go to a version where he takes the original word and he's going to map a new word, and for each letter, he's going to make a decision whether or not, well, what to return. So for every letter in word, he's going to say, does the guesses include letter? If so, letter, otherwise placeholder. So he's going to use the ternary here. So for every, you're going to have to do this. So he's going to take the word, which is a string, you're going to turn it into an array with split. So if you have hello as a string, now you have HELLO as an array. What can we do with arrays? We can turn arrays into new arrays using map. So we're going to take the word, the array HELLO. He's going to go through one letter at a time and say, if guesses include that letter, the new thing that goes into the new array is letter. If that's false, the new thing that goes in there is placeholder. So this replaces all of that. And I bet he's going to refactor even more. So you could probably just get rid of that old implementation because we know we have a new implementation that works. So, yeah, is it? Oh, do we feel at least like if we don't think we could code this, we at least think, can you follow it okay?
Yeah.
Yeah. So this, you may not, this is, and like, if you feel like you can at least follow 50% of this, but you don't think you could have written it, that's awesome. Like, be really happy with
And
that.
this is the same exact algorithm as before.
It is.
I've just implemented it with different code. The process is the same. We're going through each letter in the word, asking if the guesses include that letter, and then substituting that letter or the placeholder if it doesn't.
Yeah.
That's exactly what the old code did. If we look up the implementation of map on arrays, it's going to look like the old code. It's going to say, here's a variable, do a for loop over the thing, ask a question, and for each spot in the original thing, add either this or that, depending, like, right, that little bit that I wrote in the middle, the for loop around it, and then returning the output, that's what map does internally.
One way to really understand, if you want to get better at understanding for each and map and filter, try and write them on your own. Try and write your own version of map.
Might have that assignment somewhere.
Yeah.
I'll
Like when you
put it in there as
look at other like JavaScript code, built-in things, or a third-party thing, and you really want to understand it, a good way is to try and write one on your own. So as a personal challenge, if you really want to get good at map, filter, reduce, for each, try and write your own version of it and see how you might make it work. And I think you'll see that your understanding will pop up.
So sometimes
So some indentation stuff.
right?
I'll set this line 8. Do you want that done or not? Or we can do that some more.
Yes. So I'm gonna take this and
Is there anyone for whom this code does not make any sense at all?
Or if you don't want to say that public, you can ask one of us later in person. So did everyone see what Jason just did? Because he did it kind of quick. Undo that for a second, Jason. So we know that when we have this arrow style, if our function implementation just does one thing, which is return, we can get rid of the return, and we can get rid of the mustaches. Right? So that's a refactoring rule we can do with arrow functions. We just return something. The thing on the right can just become that. A single argument on the left can get rid of the parentheses. So now that's
see. I want to do this, but I know Gavin doesn't like that.
I don't like that. I don't do it.
See, I like it only if the context for what that variable is and what I'm doing with it are right next to each other.
Yeah.
Like, I don't have to look on any other line to see what L is and what I'm doing with it.
Yeah. But
I think that's fine. Gavin doesn't. That's too different as a style.
Yeah.
Developers were different.
Yeah.
If we were working on a project together, we would agree on a code style for that project, and we both just stick with it.
Because here's why. So does it pass the squint test? So when I look at this code, even if JSON's highlighting helps me, I can look at it and go, oh, this deals with words and letters. I can look at this and the color is trying. This code deals with words and letters. Go back to the L version. This code deals with words and L. Or ones, but L, right? It didn't actually go past. Right? I just think that if you're going to spend a few extra characters, it's better to have a few extra characters than fewer characters. This screams at me, oh, Hangman deals with words and letters. We even talk about words and letters in the description of Hangman. I like seeing those words. But I can also appreciate where Jason's. He's just so long.
So where is that being called? They have
Yes.
called,
Yeah, we're using Word. So Word up here, so add a comment above Jason. Word
I
is
am.
what? Oh, that's why we're going. Word at this point is hello. Split turns it into this. Math then turns it into a new thing, and this turns it back into underscore L. So one of you maybe below here show what math is. Yeah, what's one?
Yeah,
So Word starts out as hello, a string.
I'll get there.
Split turns it into an array one letter at a time. Map is going to do something, but joining it turns it back into something else like this. And we'll see where the map comes out in a minute. The map is going to say underscore because the H isn't in the yes, E because it is, L because it is, L because it is, and then underscore because O is not in there. And then the join puts it all back together. Now we can even simplify this even more. Yeah. So
So the split turns into an array block on that.
split takes a string and gives you back an array with one letter for every character in the string. Map takes, it gets an array and gives you back a new array. So if we want to use map, we have to turn our string into an array, so we can use map to turn that into another array, and use join to turn it back into a string. No, you can think of it as like, if I start with a string, I want to transform this string. Unfortunately, I can't use map on a string. But aha, I can use map on an array. So if I start with a string, and I want to do a transformation, strings aren't really helpful for transformations. They're not amenable, they're not helpful for manipulation, but arrays sure are. So if I can turn my string into an equivalent array by splitting it, now I have something I can work with. I can work with arrays. Now I take my array and I map each element into something new, and I get a new array. Well, I don't want an array back out, I want a string back out. Well, how do I turn an array into a string? I join it. So I'm taking some input, transforming it into something I can work with, working with it, and then transforming it back into the thing I want on the output. Oh, now these are getting really fancy. No, that was not the simplification I was thinking of, Jason.
Is that not it?
I don't think.
Yep.
There you go. Cool.
So if you were doing this on Code Wars, no doubt the top response would look more like that one.
Yep. But I was thinking about getting rid
Yes.
of the
Yeah.
arrow function. Yeah. If anybody's interested in that one, talk to Jason afterwards about why that.
Yeah.
Because he's modifying what strings can do. So
Because remember, strings are very much like arrays. And remember, arrays have all those cool functions that things that are like arrays don't. There's a couple ways to trick JavaScript into calling those functions that arrays have on things that are kind of like arrays using a little bit of voodoo. Don't do that.
So
I would never ship that code.
the last transformations, we know the rule that with arrow functions,
Yes.
if the only thing our arrow function does is return, then we can get rid of the return, and we can get rid of the brackets. That's our small code. Right in terms of like it's too simple, or right like it doesn't work.
I know it works, but it just it doesn't look right.
Yeah. So
It does. The more you write, like modern JavaScript, the more and more you write it, the more and more like.
Is it the JavaScript or is it the transformation from a string into an array and an array map and then back to the drawing? Yeah. Yeah.
So we're using hello because we used it in our past. That's cool.
Yes.
Yeah, I'm just showing you. Given this input, at each step, this is what we have. So we start with the word hello, right? Because that was our input. We split it, so we get an array with the letter split. We map it. So for each letter, so this function here is going to get called for each letter in this array.
So first H
So letter is H.
does guesses include H? No. Placeholder. E. Do guesses include E? Yes. E. Letter. L. Does guesses include L? L. L. Guesses include L? L. O. Does guesses include O? No. Placeholder. That's how that new array is built up. Then finally take that array and smash them all back together into a string.
I think now's a good time to reflect on the fact that 6 weeks ago, we were writing dead empty HTML. Now think about it.
6 weeks and a day ago.
6 weeks.
5 weeks a day.
5 weeks maybe. Yeah,
Yes.
we're in the middle.
We're not even
So-
halfway through.
I don't expect or need anybody to be able to write this. Right? What would be nice is if you read this and be like, I can follow like a third of that. Right? Or maybe you take this code back and you kind of play with it a little bit and you kind of pick it apart and see how it works. If you get to the part where you write the for loop version that Jason committed like 2 or 3 minutes ago, awesome. Right? This is, as a JavaScript programmer, like where you're headed. Right? This is your destination. like at whatever speed you get to being able to write this, awesome. If you start with, and for the next however long, you're writing for loops, cool. Remember what I said, working code is better than pretty code that doesn't work. So if you try and write this and you can't get it working and then you like stop, that's worse than being like, I'm just gonna write a big old for loop. Whatever, I know how to do for loops, I can do for loops and concatenate strings, and I got this done.
If we were working on a team and you had brought me the first version that we'd come up with, and you had tests that proved it worked, I'm like, ship it. That's
Done.
it.
We're
We're
done.
good to go. We're done here. Right? Move on to the next ticket. Because that's amazing.
So
You wrote great code.
There are teams, and I work on a team like this, where we would just commit working code that was passing tests, and then we would do refactoring Fridays. Right? So like on Fridays, we would all get together as a team and be like, let's open up the code and look for things to refactor. No matter whose code it was, we were going to spend a couple hours on Friday cracking open the code and going to find for loops like that and turning them into this as a team. Yeah. Yeah. So like, and all that code was in production, like users were using it, and it was working, right? But it could be better. Like we can refactor towards nicer, cleaner, simpler, more expressive, functional style code, but after it's working.
And because you had all the tests already set up, you could
Yep.
push it up to production.
Yep. We
I
can
like,
we can change it, test it, and push it to production like that.
I like open source Fridays
Yes.
and refactoring Thursdays.
Ah,
Yeah.
cool.
That's what I would do in my company.
And then Taco Tuesdays.
Yes.
And Capsule Friday.
The Capsule Fridays.
Yeah. So the point of
Wing
this
Wednesdays.
refactoring was what every step of the way, as Jason worked on this, as he's saving, this over here is telling him if he's doing it right or not. Right? You will get to the point, and I've done this, where I've programmed entire web applications that I know work without ever opening the browser. Right? Could have written the entire to-do list application that I live coded the other day without ever opening the browser, and I would be 100% guaranteed that it worked. That's pretty crazy.
So if we do this, also log no more.
Yep. Yep.
Yeah, notice I
use
never console.log any of this.
Hey, did you come up with that answer like the first time?
Me?
Yes.
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 I already knew that was the answer before we started.
Yeah.
Oh, wow.
Yeah, and I did it this morning with a student. Exactly this implementation. Now, how do we know this? Because we've done like 50 other things that are like this before.
Yes, over the course of literally decades.
Right?
Yeah.
Because my muscle memory is, oh, I have a string, I need to transform it, string to array, array map, map with a function, do a thing, get another array, join it back. That pattern, you're going to see this pattern for things other than Hangman, right? What if we had a paragraph and we were trying to change all of the quotes to something else, or we're trying to take out all the commas, right? Oh, it's a string, turn to an array, map through it, do some transformations, get an array back, join it together, right? This pattern will repeat. We are just now good at recognizing patterns of code that we've done before and then matching them up to problems. And you will get good at that too.
Yes, and don't compare yourself. Like, I need to be that good before I graduate the Iron Yard after 12 weeks.
Nope.
Keep in mind that between Gavin and I, there's a programmer with the experience that is older than most of you, right?
Yeah.
Between my experience and Gavin's experience, like many decades, right? Like Gavin's been programming since he was a small child. I started doing web development as a teenager and programming around 20. I'm closer to 40 than not. So somewhere like between Gavin and I is a 30 or 40 something year old programmer.
Yeah,
I've been at me, you get 31 or 41 year old program.
Yes.
I've been a professional.
Add a year for Angel.
I've been a professional programmer for 23 years.
Yeah.
I've been programming since I was, how old is a kid in like third grade? Right? Like 9? Is that right? Like 9?
Yeah.
Yeah, 9.
I've been
So,
getting paid
30
to write code for 17 years.
36
Doing
years.
it for longer, but actually getting paid to do it for at least 17
I've
years.
been programming for 36 years. Right? So like I just see these things like poof, they just appear to me in my mind. Right? Like after a lot of practice, like they will appear in your mind as well. But they're not going to for a long time.
Maybe even 18.
Yeah.
Let's think about it.
Right. But the thing to take away was, I think the neatest thing of this is, we did not get stuck in that where to start problem. Right? This helped make that where do I start problem go away. It may take longer to do this method, for sure. It may take longer, may seem even take like 3 times as long for you to start this way, but it does get rid of that where do I start. Because we said, oh, I know where to start. I'll just start with the very simplest hangman I can possibly think of, just the letter A. And everything grew out of that to a complete implementation of Hangman, and then finally a refactoring to super awesome ES 2015 syntax with a functional style map and split and join.
Also, when we do our bug handling, now we have a plan of action.
Yes.
So we don't have to feel like we're just flapping in the wind whenever a bug appears.
Yes, for sure. Yeah, like when a bug happens, like we discover a bug now in our Hangman code, what's the first thing that we do? We don't go change the code. We write a test to reproduce that scenario. So like what if somehow we got like, I don't know, an undefined error? Like I can't even think of what an error might be. Like we get an error, right? The very first thing we do is we take the error that we found in the browser or wherever we found it, and we come back and we add a test to show that it's actually a thing. Then we keep updating the code until that test also goes green, ship it back to production. Right? It gives us a place to put that fix.
I made a bug,
Oh, okay, cool.
then I fixed it
Cool.
by hitting undo.
Hitting undo, right. But like maybe there's an input we don't know about yet. Like we've thought about all the inputs we could think of, but there's a case that maybe a user thinks of an input we never considered. Like, what if they put in like a Unicode character? Or what if they put in something else that we weren't expecting, right? We may get a call like, hey, your Hangman program's got a bug. Awesome. How did you make it happen? Oh, I typed in this. Oh, their word was supercalifragilistic, and they typed in the Unicode snowman, or they put an emoji in there. Cool, let me go put supercalifragilistic as my word, and an emoji as my character, and see what happens. Oh, shoot, yep, there's a bug on, like, syntax error, no, not syntax error, like unexpected type on some line. Work on the code until that goes away. All my other tests still pass, ship it to production, and then yay, now you can use emojis. You're gonna try an emoji?
Mm-hmm. If I can spell emoji.
Yup.
Have you seen the movie yet?
Yep.
Wait, is that out?
Oh, terrible.
It is the most spectacularly mediocre movie I've ever seen in my life. It was so.
Is it like bad enough that it's like worth watching?
It's not. Here's the thing: is it's not bad.
What?
It's just so mediocre. Like I can't tell you how like incredibly just like flatline it is right in the middle. Like there are jokes and they are funny. Are they like belly laughing funny? Not really. Do they make you cringe because they're bad? No, not that either. They're just like you're just like.
So a little bit more here.
Yeah. Yeah. Yeah.
I'm curious now.
Yeah.
It's I can't describe like how mediocre it is. It's
So the line from the trailer that got me is like, we're number 2.
yeah. There's about 4 more of those jokes. Like just doing my duty.
Yeah.
Like and
But, like,
those
the
are some of the
song-
best jokes in the movie. Yeah.
Okay.
Yeah.
It's not that they're like scatological humor, it's just the fact that like it's a good pun.
Yeah.
Like we're number 1.
The fact that the main character is the meh emoji pretty much sums up the movie. Like I don't know if they did that on purpose or not, but like, good on them.
Right. Put some emoji in here. See what happens. You got an emoji.
Is the animation any good?
That's fine. It's Sony, so is it Pixar? No, is it? It's whatever. Yeah. If I can,
I always go to Unicode Snowman for you.
I got it though. That's not emoji though. Hang on, I got it. It's coming.
You all know that there's the keyboard viewer. You can copy and paste any character coming through the emoji. There's the character viewer, and you can if you go to your system preferences keyboard, the checkboxes that show the character viewer. You'll get a icon in your toolbar that has
Oh, are you shitting me?
a keyboard switcher and a character viewer. And inside of that, you can filter any kind of character, including emoji, mathematical expressions, all kinds of stuff.
I found a PDF version of it. I can't find a not. I wanted to use Call Me Ishmael from Emoji Dick. Man. Oh wait, here's a website.
So we don't get the pleasure of watching these.
No, yeah, here we go. Hang on. 3 fingers over here. So there is a adaptation of of Moby Dick, written entirely in emoji. And you say this because most of you probably don't know the roots of emoji. So in Japan, on Japanese phones, you got all of these extra icons that people started using as sentences, and you could send, like, rather than texting each other like, "Lol, what are you up to?" like we did in America. The Japanese people were infinitely more creative and just sent each other like strings of symbols, and that's where emoji came from. Eventually, they got adopted into UTF-8. Now they're on all of our devices everywhere. But that's where they came from, and I was hoping that it's for yeah no.
I guess we really like.
You can just buy the softcover one if you want, but probably because it's a limited edition.
What are you
And
looking for?
I don't even know right now. My cursor actually, my cursor. So I really want this to be. So the PDF, I couldn't select them in the PDF.
No, it's Moby Dick, written entirely in emoji.
So I'm gonna let this load over here, and then y'all can look at it. Maybe I can find. So this is it. Here we go. Yeah. So there's reasons why these symbols are chosen. So this is my substitute for a pistol and ball. Yeah. Yeah. If you're fluent in emoji, like most of this would make more sense. Like there's a weird, bizarre subculture language to it all. It's yeah. So I'm gonna give up on that, and I'm just going to grab a couple emoji characters. We'll get this one.
Can you move this up a little bit?
And let me get one more. Like the
Yeah.
goblin here, ogre. Alright, so there's an ogre in my phone. That's my emoji message. And I've guessed this. So what I should get is this underscore. Womp womp. So yeah, okay. So the emoji test failed. It expected it to be this, and it received that. That's a problem. I believe the map function on splitting the string is not handling the multi-byte characters well. So if I wanted this to support emoji, I'd have to spend a little more time learning about UTF-8, multi-byte character strings, and text encoding, and fix that, right? I'm not going to do that right now, but
That's the point. Like, if you got a call and said, "Hey, your stuff doesn't work for emojis," the first thing you would do is write a test to prove, yeah, emojis are a problem.
yeah. Hey, look, it almost even worked. I see my guy, and then I see an underscore, but there's something, this weird little symbol in the middle, right? I'd have to investigate that, write some code that handled that correctly, yeah. So that might work, right? If that's something that they should be inputting. right? But what if I don't like, oh no, that should be a feature. Like, because we're not talking about emoji here, we could be talking about multi-byte characters, which could mean somebody's typing their input in Hebrew or in Hindi or in Mandarin or something, and those characters exist in the same sort of text encoding space as emoji characters. So if I'm going to have my app support multiple languages, then it needs to solve the same problems it needs to solve to work with emoji. So maybe I don't want to just validate that they're only putting in A through Z in the Latin alphabet.
So the point is just that, yes, you could prove that it's a failure, and you could choose not to support it and filter it out somewhere else, but this proves that it really is a problem. You don't know it's a problem until you can prove it's a problem. This proves it's a problem. And the reason we're able to prove it's a problem is we have a test suite that helps us know, is it really a problem? You didn't have to go visit the site, you didn't have to go make a hangman game that had this in it, and then use the user interface to put in emoji. You can just do it right here and say, yep, yes, customer support, emoji really is a problem. We will open a ticket that says either fix emoji support or remove its capability in the system. Step one of getting a bug report is proving that really it's a bug.
Yep.
Any questions on the testing part? I know we did some funky code, some cool mystic stuff, and then weird emojis. Any questions on this part? Right? We could have also started with our implementation and then written all these same tests. Right? That would have been test later. Write the hangman code, and then come back along and then write test cases and say, okay, if we give it hello and it gets an L and E, we get the right thing, we sure do. Totally fine if you write your code first and then your test. Right? If you feel like I don't even know where to start, right? Write your code and then try and write tests. I will say, however, the bigger the code is, the more code you have, the harder it is to write the test afterwards.
There are also more assertions in jest than just equality, which is 2B. There's a whole lot more. You can look in the docs.
There are matchers. Does it match this pattern? Is it more than this and less than this?
Yeah. So you might want to say when I filter these things, is the result less than what I started with, right? You can write that. So there, instead of 2B, there might be less than, and you might just put less than in the original length for the length of what you're filtering. There's a whole bunch of the different types of assertions. The equality assertion is probably the one you're going to use the most often. As you see, I got through all of this without needing to assert anything other than equality. But there are situations where the test you'll write might be asserting something other than just is this equal. So, and those are in the jest documentation if you look at what they are, and they all work basically the same way.
Is that mostly for when you don't know what the output's going to be?
It can be, like an example, like is it less than? Maybe my test has randomized inputs, right? Which is not a bad thing to do in a test, is randomize the data going in, and then asserting that what's coming out. You don't know exactly what's going to come out, but you might know some facts about it, right?
Or if the code says something like, here's an array of things, remove some of them, you don't care which ones were removed, you just want to say, if I started at 10 things, I should have less than 10 things now. Right? Because you could write one test that says, if I give you 10 inputs into this array, I want fewer things back out. I don't know what the filter would be. You could write a test that says, given 10, I should get back less than 10. And then another test to say which things got eliminated.
Yeah.
So you can have two tests. One of them says, hey, let's get rid of fewer things.
Given these 10 things, one of which is B, make sure the output does not include B, right? That might be another matcher. So those two things combined, you never have to do an equality.
Is there a time where you'll have multiple tests for this, right?
Yeah. You might have a test, you might set it up so that all of your unit tests that test the business logic are in one place, and all of your functional integration tests that test the interface are in another place, and maybe they're all running while you're working on the code.
So for instance,
separately.
this just tests
I don't know if that
JSON's
answers your
hangman.
question.
It only tests this hangman function. But if we were going to go use this in a web application, an Express application that actually renders something to the screen, maybe we have a whole nother directory of tests that tests all of our HTML. So given the hangman, We don't want back just a string of things. We want back a div and a span and a thing, right? So we want span underscore, span underscore, span e, span underscore, right? So we'd have another test that tests the mustache templates. And we'd have another set of tests that say, hey, when you type in e and you submit this form, the right thing happens. You might keep those in separate parts of your test suite so that while you're working on the hangman function, you're not running all the stuff that deals with the web yet. But then when you've got that working, yeah, you'd go back and run those tests to make sure they're still working.
Hey Gavin, are there any web frameworks that enforce that pattern?
Yes, in fact, there are.
What might one of them be?
It might be Ruby on Rails. Yes. One of the great things about Rails is like I think they were really one of the frameworks and communities that brought a strong testing methodology and passion to the web community, because there wasn't people were doing tests, but not with the fervor that the Rails community tends to bring towards testing. So much so that when you write your code in Rails and you make new things, it will like in Mustache, we create a Mustache template or we make a new app, app get slash. In Rails, when you say app get slash, you do the thing that creates that. It creates a test for you at the same time. So it's constantly reminding you, like, yeah, you should be writing this code. We should also be writing tests. So it reinforces that behavior through the way the framework works. Cool. So, no more questions. We will be creating a homework, because I think the homework that's in the system is for testing an Express app. We didn't go into testing Express apps. So we will, there's a homework in there that says test your list, I think. I'll have to go see what it's testing. But I think we're going to create a homework for this afternoon while we're eating our lunch.
So let's say you, just for some context, let's say you were building your Express app that played Hangman, right? So you might keep all of the code that handles the incoming requests, right? The app.get, app.posts in there. And then you would have this Hangman function in another file, and you would import it in. So when somebody posts a letter, you would do the job of taking the letter that they asked and adding it to the guesses that they've made so far, then call the function that you wrote that's well tested from the other module, and then take that output and then render it back in your template, right? So all of that code in the Express server file really is just gluing together the user input to some output, but your business logic exists somewhere else. And that's where the MVC pattern, I believe, was even mentioned in the reading yesterday. And that we talked about previously, that little triangle that Maria came up with, and it's on the board. It's on the back of that board, I think, or it's on the board over there, wherever it is. I don't know. Yes, that pattern that exists comes into play. So this would have been the model, kind of, that we just wrote today in that triangle. Anyway.
So expect homework soon.
Yep.
Bing.